All right, so that's our definition. So let's unpack this a little bit. So it says if f is continuous on A to B and differentiable from A to B. So that means it has to be both continuous and differentiable for this theorem to go ahead and work. That there exists a point where the derivative is equal to 0. And this, let me give you a picture of what this looks like. Actually, let me change this. I'm changing my mind again. Give me 1 second. All right, sorry, changed my mind a few times with what I wanted to use as an example. All right, so let's unpack this. First, it's a polynomial, correct? So, and this is f of x. So f of x, whenever it's a polynomial, it's really, really nice. We know it is both continuous and it's differentiable. That has to be the first check. Now, as an aside, sometimes it's always really good to talk about what's not. What is this a graph of? You got it. You're absolutely right, Shelby. This is a graph of the absolute value. So if I said my interval here was from A to B, is this continuous? Yes. Is it differentiable from A to B? And that answer is no. So Rolle's theorem does not apply. Rolle's theorem only applies. You must have both the fact that it's continuous and differentiable. All right, so let's talk about what this means and really unpack it. It says if f of A is equal to f of B. Well, what do I have right here and right here? If this is my point, if this is my point A and this is my point B, well, what does f of A equal? Yep, f of A is equal to 0. Is f of B also equal to 0? Yep, those are the zeros of the polynomial, correct? So the zeros of the polynomial, now Rolle's theorem applies, and what Rolle's theorem says is that if this happens, if I can find any 2 points where f of A is equal to f of B, then there exists a point where the first derivative is equal to 0. Where is the first derivative equal to 0? First derivative is equal to 0 right here, where this is some value c. So I can say that, I already have it there, so I'll just highlight it. I can go ahead and say that f prime of c is equal to 0. I really like the way you guys participate in chat. It makes me feel like we're almost in a classroom. So I really do appreciate this class. I wish I would have you all in the classroom. I think we would have a lot more fun. Do you see what this is trying to say? So in essence, and it doesn't have to be the zeros just say, okay, I can prove and I can say, I know that these two are equal. So since they're equal, sometimes it had to go up and it had to come back down. It doesn't matter if it was anything that you have anywhere. It doesn't have to be a zero, but if you have any 2 points, like a vertical line where you can say these two values are equal to each other, that you know that someplace in between those you have to have some kind of a point. It's whatever goes up must come down, right? It's that kind of idea. Okay, now for the work. You ready? All right. Julie, you're ready. You can do this. Find an interval where Rolle's theorem applies. Now, I gave you one that was nice and factorable, correct? And I gave you the hint in the last question of what we're going to go ahead and look for. So Rolle's theorem would apply if I factor this, right? So if I factor this out, I would be left with x squared minus 7x plus 10, or if I factor it again, we would go ahead and be left with x minus 2, x minus 5. So if I go through and sketch this graph out, and I really do hope this is what your intermediate algebra or pre-calc teacher had you do, just to sketch it first. I know a 0 happens here. I know a 0 happens at 2. And I know a 0 happens at 5. This is a positive, so I know the graph comes up, starts down, ends up. It's going to come up. I don't know how high it's going to go, but then it has to come down. Goes through this. I don't know how low it's going to go, but then I know it must come up. So again, what does Rolle's theorem say? Is that any point, if in this what happens, that f of 0 also equals f of 2, which also equals f of 5. I just happen to use the fact that it's 0. Does it have to be 0? No, but it's a heck of a lot easier to find the zeros of a polynomial that are equal to each other than trying to find and say the value at 1 or 2. Questions so far? Okay, so where are the intervals that I know that we can find? I have 2. I know I have an interval between 0 and 2 is an interval where Rolle's theorem will apply. My next interval is between 2 and 5 where Rolle's theorem will apply. No. Okay, so the question was, would infinity ever come into play? And we're not looking at that. All right, so my next question is going to be, where does f prime of x equal 0. Because wherever this happens, Rolle's theorem tells us this must exist. Not a, I want the number. Michael, you are 1,000% correct. It appears to look like it's 1 and 3.5, but appears is not enough. What do we have to do? To do this, one, we find f prime of x, and then solve. Where does that equal 0? All right, so what did we start with? We started with x to the third minus 7x squared plus 10x was f of x. So the first derivative then is just using the power rule. We get that to be 3x squared minus 14x plus 10. And no, it does not factor. So since it doesn't, I had to pick one of these to show you that not everything in life always factors, right? So do you have to use a quadratic formula? Yes, you do. Now, let's go ahead and run that through. So quadratic formula gives us that our two x values are going to equal negative b. So it gives us a negative of negative 14. So it's a positive 14 plus or minus the square root of 14 squared, which is 196 minus 4 times 3 times 10, all divided by 2 times 3. Or x is equal to 14 plus or minus. All right, so underneath the square root, what we end up having here is 196 minus 120, which gives me 46. Yeah, 46. All divided by 6. Or I'm just going to do this one time because I need to. That should give us, what is it? 4 times 19, yeah. So that will give us 2 square root of 19, all divided by 6.
Professor, I don't mean to interrupt.
Professor, yeah.
Yeah.
It's 76.
It's 76.
46.
Oh, thank you. Thank you for interrupting me. Please always do that. My math is bad. I'm not going to even blame that on my lack of coffee this morning. All right, so you get all of these things, and you're going to get down, if I run the math out, you're going to get two different values. You're going to get one value of x is equal to 0.88, and one value of x that is 3.79. Now, let me see if I still have access to my calculator. I might have logged out of my trial version. Oh, I have 25 days left. Fantastic. All right, so Is everyone all right if I go ahead and turn the iPad off for a second so I can show you how wonderful the calculator I had you guys get is? All right. Where'd my calculator go? All right, can everyone see the calculator? All right, perfect. All right, you can tell I was doing trig with this last. Let me clear this out. Now, this has a beautiful thing. You see where it says polysolve at the very, very top of it? Above the cosine button? All right, hit second, polysolve, and it only does quadratics and cubics, but that'll be enough for us. So we're going to go ahead and pick question 1 and hit enter. And my a value in this case, since we're solving it for the the first derivative, a is going to equal 3. What happened? There we go. A is equal to 3. Where's B was negative 14. Do not use the subtraction sign when you put this in here. If you use the subtraction sign, it will give you an error. So make sure you use the negative when you do this. Then hit enter. And then C was equal to 10. What is going on? And then arrow down and hit solve. And lo and behold, you have your 2 different values. This is why I don't let them use this calculator in college algebra and in intermediate algebra. It works. It's quite lovely. Now, on a different note, you could also use a table of values to find out where the zeros are and find them inside there. Yes, I know. I am telling you, bar none, this is the best calculator you can have. I even think it's better than a graphing calculator. I don't like the graphing calculators for several reasons, but because I want everyone to have a picture in their head what a graph looks like. I think it's essential to understanding calculus is to when you look at a graph in a function that you kind of have an idea what it looks like. So, you know, it's similar to art. If I say the Picasso's, Cubist period, you should understand what that kind of painting looks like. It's just something you need to know what a rough idea. Who told me what?
Oh, no, when I was like in 6th grade, we used to play like around with the calculator. We like be nerds with it, and they told us all the secrets about it. And they said, "Don't tell anybody inside college. Let them find out."
Oh, yeah, no, I just don't let them use this in college algebra or intermediate algebra because there the skill is how do you use a quadratic equation, right? I'm assuming that all of you in Calc 1 should be able to use a quadratic equation. You should be able to add and subtract fractions. Now, if you cannot do those things right now, I am 100% telling you practice them. Check your work in the calculator. All right, because there are things that you absolutely do need to be able to do, but at the same point in time, there's several times in class where time is of the essence, especially when you're doing your homework. And if you're thinking about what we're talking about here, we had so much to practice with this one particular question. Let me pop my iPad back up. Just know that my screen gets a little wiggy when I do it this way. So I'm going to turn my video off. when I use this particular receiver, my computer doesn't like me very much. It's using my graphics card is not. I'll put it to you this way: the computer is from the college, so my graphics card is not what you would consider fabulous. But to do all of this work and then make a very mistake at the bottom because you put something wrong in the calculator, I want to know that you understand how to do all of this. So it's a way of checking your work. The other thing is it should really make sure it makes sense to you as far as what is going on. Now, notice what I'm talking about both here. Let me get my pen back. I am talking about the x value, right? So when I find x is equal to 0.88 and 0.375, if you look back to what a couple of you said in the chat, and I think it was Nicholas that was going through, this is 0.88. You are close with 1. Over here, this value here is 3.79, but it gives us that exact value where the derivative of the function is equal to 0.